Okay, the second video for the MultiSim lab here. We're gonna dive in, make a circuit. So going back to MultiSim here, and I'm gonna select these guys. Something I did not show earlier, which is useful, is how to select multiple things so you can move and delete them. Shift click does work. That was shift on a Mac, different on a PC probably, but control click on a Mac lets me drag marquee across multiple things. Does the delete work? No, but the X is working there. So we're going to start with a AC voltage source. We're going to grab this guy over, and this is a palette. It says sources. Got all sorts of cool choices here for doing all sorts of things. We're just using an AC source, voltage source. We're assuming this is an audio input. And I'm going to put this over here on the left of the sheet. In fact, you're going to need the room, so kind of upper mid left, like about right there is going to work for you. You're going to need the real estate here. And let's, and if you're super anal retentive, maybe you could put it on the line. I'm going to do it over here. I really know I need the space. And this is a voltage source. It's 1 volt, 1 kilohertz. We'll stick with 1 kilohertz. We do want to change it to professional line level. If you double click on the 1 volt, up pops the value. You can do it over here in the items. I'm just going to type it in here. It's really nice. You can type right on the 1 volt here. And let's make it professional line level, 1.228 volts. While we're here, just want to show you something. You can move by an order or magnitude here by factor of 10, make it bigger, 12.3, or down. So this is kind of useful. You'll find this very useful when playing with resistors. But we want to be on 1.228 volts, which is defaulting here to 1.23. That'll work for me. And so there we go. There's our virtual noise sound generator. Let's connect that to ground, the negative terminal. So let's put a little conductor on it. If I click on the negative terminal and I drag, I'm now making a wire here, and we'll put ground down here. I found that hitting the JK, which hits a junction, is the easiest way to end it. Clicking does end it as well, but I find J easier. Now we're going to put a ground next to this. The ground terminal is under here under the ground palette. And you can see there's a ground, and you can drag it over and attach it. Boop. Pretty easy. Hitting a G will also move a ground out here, so that's pretty cool. You want to use that one as well. So we put a virtual ground on this, and now I'm going to consult the PDF, see what else we need to do here. I've kind of set all of this. We're going to draw off to meet our first component. So we're going to do a right angle here. So again, clicking on the positive terminal, there we go, and drag upwards. What's cool, if you click, it'll let you turn the corner. You like that? That's pretty cool. And we'll put our first component here, and I'm going to put another J. J ends it, junction. And I believe we're putting a resistor shunting to ground. I believe it's a 10K resistor. So let's do that. We're going to drag over resistor, over, or I'm going to escape. I can just hit R to add a resistor. And I'm going to put the resistor here parallel with the noise source, with the voltage source. So I'm going to put it right there. Now I need to rotate that. So I'm going to hit the rotate tool. Rotate it 90 degrees. And let's connect these two together. Again, you can click right on it and drag right to it, and it automatically makes a junction. And we want to add a ground to that as well. So I'm going to hit the G, or you can visit the ground palette over here. Ground palette. Drag that over. Or, as I said a moment ago, I could hit G and do it and add a ground. So, and there we go. And we'll connect those. We may have made this a little bit bigger than we needed to. Let's do a little housework here. I don't think this needs to be so big, so I've clicked on it. I'm going to drag it up a little bit. Just make it a little smaller here. Later on you're going to need the space. And I'm going to drag the conductor down here, make a junction. Perfect. And that's 1 kilohertz. I'm anal retentive, so we're going to drag this up here. Kind of matches there. And 1 kilohertz is not the value we want. We want a 10K resistor. So if I double click on the value of the resistor, I could type in 10K, or I could hit the order of magnitude button. Boop, I'm up to 10K. That's pretty cool. And what else are we drawing here before I end the video and go on to the next one? We'll add one more thing. We're going to add a buffer amp. So the input, this 10 kilohertz resistor here defines the impedance to ground as 10K. And that's about normal for a line level input. Usually they're a little bit higher, but that sets the input impedance, and we want to do that. We want to set the input impedance because the op amp that we're about to go into has a very, very high input impedance. So this will lower that down to 10 kilohertz. Now I made a mistake a couple minutes ago. I want to drag this down. We have to put an op amp here. Well, there's room for the op amp, isn't there? Yeah, there's room. We'll leave it just the way it is. Let's bring over a standard kind of generic theoretical op amp, a 3-terminal op amp here. We'll drag this over here. Kind of put this, I don't know, put it right here. And we're going to put our, I'll drag it one over so it's right on the darker line here. And let's bring in, let's put a junction, a J, right there. And then I'm going to drag to the non-inverting, the positive input of the op amp, and connect it. And I'm going to end the first video here. Just keep the video short, and we'll talk about the op amp in a second. Okay, thank you.